In this second tutorial, we will evaluate a limit from calculus using the difference quotient. So let's flip on over to example 4, our final example. This is a limit from calculus, and this right here is your difference quotient. Now, right now in this problem, it's really just going to be some algebra to work with. This difference quotient is going to have more meaning when we start to look at our first calculus problem, the tangent line problem. But for right now, let's just understand that it's called the difference quotient and learn how to algebraically work with it. So we're given a function f of x, it's x squared minus 1, kind of a simple function, and I'd like to find the limit as h approaches 0 of f of 3 plus h minus f of 3 divided by h. Obviously, direct substitution would be the best idea to do, but we cannot plug a 0 in for h. If we plug a 0 in for h, of course, we get a 0 in the denominator. If we plug a 0 in for h in the numerator, we get f of 3 plus 0, which is just f of 3. We get f of 3 minus f of 3, which would be also 0. So that's the good news. We have our indeterminate again. So that means that there's a common factor that will cancel away. And in fact, since there's only one factor in the denominator of h, that must be the common factor that's going to cancel away. So let's see if we can find it. What I'd like to do is break this numerator into the two pieces that it is. So f of 3 plus h, I'm going to put in a blue box, and I'm going to do over here. F of 3 plus h. So f of 3 plus h is basically taking the 3 plus h binomial and replacing x with that. Since f of x says take something and square it and subtract 1, f of 3 plus h is going to be the something squared minus 1. I'm just taking my new input, squaring it, and then subtracting 1. Squaring a binomial, of course, is the binomial times itself. And when I FOIL, I get 9. Outer terms are 3h. Inner terms are also 3h. And last terms are h squared. And then the minus 1 still. If I can rearrange my terms here, I'll put the h squared first, make my 6 h's, and the 9 and negative 1 make an 8. So that'll be my blue box. That's that part of the numerator. The other part of the numerator is f of 3. Obviously, that's not as difficult. Let's do f of 3 down here. F of 3, again, f of x says x squared minus 1. So f of 3 would be 3 squared minus 1, which of course is equal to 8, and we're finished. So that's the other part of the numerator. So now that we have both parts finished, let's substitute these two expressions into the numerator and see where we are. So we've got the limit as h approaches 0. Of course, I'm still writing my limit symbol since I have not yet evaluated it. H is in the denominator. This f of 3 plus h, we've already come off to the side and figured that out. It's right here. H squared, actually, let me color code it. H squared plus 6h plus 8. And then we've got our minus sign. And then the other part of our numerator, which was f of 3, we already did that, and that was an 8. And so there's our 8. Great. Now we're just ready to finish our algebra. It looks like the 8 and negative 8 cancel away, and in fact, those numbers, whatever they are, will always cancel away. The only things that can remain are things with h's in them. And up in the numerator, we have h squared plus 6h. Do you see the common factor now? I hope so. Let's factor it out. We've got the limit as h approaches 0. Now the numerator, I can factor out an h and be left with h plus 6. I'm just pulling out the GCF. And now that h will cancel away, whoosh, like we knew that it was going to right from the beginning. Limit as h approaches 0 of the only thing left now is h plus 6. Finally, I have an expression that I can plug my 0 in for h. And if I do that, I finally can do my equal sign and have 0 plus 6. So our answer to this one is 6. So it is a little bit of algebra. It's just some function notation in the difference quotient. We got this function notation to go and figure out this thing. We got this function notation to go and figure out this piece. Put the pieces together, you cancel out your stuff, factor out your h, cancel it away, and finally we can evaluate the limit. Let me say one last time that the limit symbol is in every step along the way until we can evaluate it. Then we can put an equal sign and get the number or expression that our limit is equal to. Thanks for working with this difference quotient. Again, it's going to have more meaning when we look at the tangent line problem. I'll see you in class. See ya.